Good afternoon, people. Yes, it's Kali, and of course we're going to be talking about neutron decay cosmology again. But hey, so one thought I had earlier today was, and this is the first thing I'm going to look at, is I'm curious in reading Einstein's papers. I want to look at them and talk to somebody. Is what choice of word he used in German, and what is the meaning exactly of that in German? Because regarding gravity, it's like everyone talks about it as a curve, but then all of a sudden, or like an angle or something, and all of a sudden it was like, wait, like a gradient in English has both meanings, that a gradient is a physical angle or slope or curve, that would be a change in gradient, it would be a curve because it has to change. But still, I just was curious in his papers what words he was using exactly, because it seems like curve, like I just wonder whether it's like there was a more general thing where the gradient, and therefore it was more about density rather than actual physical curve, because a gradient is a more general word. That was the first thing. The main thing today, though, that I want to address is what I think ends up being the fundamental thing about neutron decay cosmology. And I'll get to this. Okay, so it's all about neutron decay. You can't see the N. Let's put it up here. Right, here's a neutron. It's an up and a down and a down. Right? And up. And up. Two positive charges. A down. And a down. And we take one of the ups and one of the downs and we smush it together and we make a mass particle. And we take the other one and we make another, there's a mass photon. Here's another mass photon around that one, so now we have a neutron. This is my model, right? Boop. There we go. Okay, and then the neutron decays, because what happens is this photon breaks apart into the yellow and the blue components. Okay, the blue component becomes the positive charge of the proton up here. And the negative charge becomes the electron over here. And then there's a antineutrino, which I'm curious about this arrow, but let's not get into that right now. But the antineutrino, which has to do with taking the charge, spinning the charge on and off in my model. Its functionality is, this is the spin that came out because this photon decayed. And it was rotating and now it's not, it's a static field. Okay, so that's the principles. So, but the thing is, so we have the proton. Proton is neutron point particle. Let's say just call it that. Femtometers, whatever, tiny. Boot. Okay, proton. Same deal, right? Fairly comparably sized in the grand scheme of things. And we have the neutrino, which we don't even know how to measure its sizeness, I don't think. It's a very weird thing. I suspect it's just a swirliness of Planck size. And that's why we can only detect them by their interaction when they put on or off some charge. Okay, but this last item on the agenda, this electron over here, it's a funny thing about electrons that a diagram like this really doesn't express to you the fact that this is a point particle, this is a point particle, this is a point particle maybe or something. But this is def not. And even when you look up how big an electron is or what the electron orbital is, that's sort of for a percentage mean distribution, okay? Because any given electron, and any physicist will acknowledge this in a weird grudging way probably, the truth is that one single electron, if we had an empty universe and we had one electron sitting there, this electric field would extend the entire universe. It would get weaker and weaker and weaker and weaker and weaker, but it would extend to infinity. The outward pressure, electrostatic pressure, created by an electron has no limit in a weird way. The amount it exerts, the pressure it exerts, and the way we measure it is limited. But one electron field, one atom of hydrogen would take up an entire cubic mile. If it had to, if that was the situation. You had a completely empty, completely, truly, absolutely, completely empty cubic mile. And you put one hydrogen atom in it. That hydrogen would fill, or because it has an electron, the hydrogen would fill that mile and exert the tiniest outward pressure still. Because it kind of wants to extend to infinity, and you're stopping it at a mile. Granted, it doesn't have much oomph at a mile. That's not the point. It extends. This is why when a neutron decays in deep space and becomes this, a hydrogen atom, it takes up a cubic meter now. This is the dark energy. It's the electrostatic repulsion from the electron that's generated. And just as an extra side thing to what I've been doing in terms of this. So I went on and did some calculations. I could do them live for you, but I didn't. I looked them up. You can look them up, whatever. Point is, I looked up what they call cross-section of a proton, a neutrino, and an electron in free space at a density of 1 particle per cubic meter. Because that's the estimated density when I looked it up of deep space and voids and stuff like that. About that, which also happens to be the cosmological constant, which is like, okay, so it's balanced, right? Exactly. Every meter or so, a neutron appears to fill up the gap of the meter, because that's what the cosmological constant is. And how does it fill that gap? It fills that gap by releasing a neutron, which decays into a proton, a neutrino, and an electron. The electron takes up the room because it's an electric field. And so, this is the fundamental thing, though. Oh, yes, cross-section. So I looked up the cross-section of the proton, and neutron, and electron at a density of 1 meter per cubic thing. And the neutron moving at near relativistic velocity, because my expectation is that the neutron was excited, right? The neutron was accelerated by the gravitational field of the event horizon. So it falls through space-time at 0.999 c. So it gets to travel pretty far before it decays. And then it decays and expands and causes dark energy. These particles have a cross section. You can look it up, but I looked it up. It was in the order of 10 to the minus 31 barn. In that realm. So that seems quite low. If there's a physicist who wants to do some calculations for me to prove that I'm an idiot or something like that, I would love that. So proton, a neutrino, and electron, antineutrino, and an electron. These 3 particles. So one per cubic meter, 1 per cubic meter, 1 per cubic meter, and we'll have the neutron flying through it. We'll imagine that these are still, because locally they will be still. Okay? So if anybody wants to do that, feel free, but I'm just explaining that this is where it comes from. It's this freaking decay, because all of a sudden you have an electron. An electron pushes outward. The electron field extends. It's like the opposite of gravity. It's the compensation for gravity. It's the stretch that you get, or it's the pulled inness that you get, because this got condensed, so this had to be stretched out a bit. This is it. That's where dark energy comes from, in my opinion.